Hey, in this video we will be learning about object-oriented programming, the heart and the soul of Java. You have to be really attentive in this lecture as this is the most important topic of Java. Not just Java, of all the object-oriented languages in the world. So let's objectify. Today we will be learning about classes and objects, about attributes and methods, abstraction, encapsulation, and other things as well. But let's not complicate it. Let's start with the first topic, that is classes and objects. Let's understand the concepts, okay? And listen to me very carefully, okay? So let's get started. What is a class? If you go by the textbook definition of a class, you will see often that it is written as the blueprint. But if you do not understand what a blueprint is, let's break it down. A class is basically a set of rules about how to create an object. For example, let's say you have a rule book. Okay, this is a rule book of how to create a car. This is a rule book. Okay, how to create a car. This is like a set of instructions. So basically a set of rules, call it instruction, whatever. So it is the set of instructions that define how to create a car. Okay, we'll be taking the example of a car just to understand the details in more depth. Okay, so it is like a blueprint. It is like a set of rules of how to create a car. Okay, and every object must have two things. First thing is called attribute and the second thing is called method. Now what are attributes and what are methods? Let's understand. So attributes are basically called properties. So attributes have a synonym. It's called the properties. But in the domain of computer science, we will use this term attributes, and we will also use this term as well, methods. Okay, but what this basically means is that properties and abilities. Let's focus on these two terms for understanding what this means. Okay, so every object should have two things, properties and abilities. Properties are passive. For example, if you are creating a car, okay, if you are creating a car, it must have a manufacturer. Let's say maybe Honda, maybe Suzuki, maybe something else, right? This is called manufacturer, right? It can be it can be Mercedes, it can be Audi. It is the company name. Hope you get it. It's the company name. Then you should have another property, which is the model. Now, of course, a company can manufacture thousands of different cars, right? For example, Honda can produce maybe City, Amaze, etc. Right? Honda can also produce maybe the racing cars that you see, right? So everything has a model. Every car has a model because every manufacturer creates like thousands of cars, right? So they have different models. So okay, so a car must have a manufacturer. A car must have an attribute, right? Let's think of some more properties. Maybe color. Your car should have another property, which is the color. It can be red, it can be white, it can be black, it can be blue, green, orange, whatever. These are properties. Okay, these are the properties of an object. These properties in computer science are called attributes. Hope I'm clear till now. Let's have another property. Let's see if we have another property, fuel, right? Now fuel could be petrol, or it can be diesel, it can be electric, it can be hydrogen, it can be anything like that, right? So fuel, it is another property. Are you getting it? These are the properties of a car. Okay, these are what? Properties. But what do we call properties in computer science? We call them attributes. Write it down. Attributes are the properties of an object. Okay, that's it. These are passive. These are just passive. Then we come to the second part. an object should have attributes and methods. What are methods? Abilities. A car has to do something, right? A car has to do something. It should accelerate, it should brake, it should honk, that is press the horn, right? Beep beep. It should start the engine, it should stop the engine. These are something that you can do. That you can do. Are you getting it? These are something that you have. Do you understand the difference? These are the properties. These are the properties that you have. These are the abilities that you can do. These are active. Okay? Think if I come from an English perspective in a grammatical way, think of it like a verb. Okay? Verb is something that you do. Fighting, wrestling, eating, doing something basically. So an object has two things: properties, that is basically what it must have, that you have, right? And something that it can do, it must do it. Those are the abilities, and we call them methods. Are we clear here? So methods are, maybe you can accelerate, maybe you can brake, maybe you can honk, maybe you can engine start, you can start the engine, you can stop the engine. These are methods. Okay? And of course, I know if you have gone through the functions lecture, yeah, I know, right? Methods are basically functions within a class. Are you getting it? Methods are basically functions within class. If you have followed the second lecture of functions, you will notice I have repeated this term again and again, that methods are basically nothing but functions within a class. It is something that an object can do. So let's have a recap again. What is a class? Class is a blueprint or a set of rules that defines how an object should be made. And it has two things: what it can do, that is the methods. These are something that you can do. You can accelerate, you can brake, you can honk, you can start the engine, you can stop the engine. And what it can have, the properties, the attributes. This can be manufacturer of the car, this can be model of the car, this can be color, this can be the fuel. Okay? And what is a class? Class is like a rule book, it's like a blueprint, it's like a set of rules for how to create an object. Let's give you another example, okay, just to make it clear. Let's say, okay, let's think about it. Let's take student. Okay, let's take a student example. This is a student. Okay, now first, to create this student object, I first need to have a rule how to create a student. Okay, how to create a student. So for this, I need to create a student class. Now, a student must have some properties and a student must have some abilities, right? So, some properties, some abilities. I mean, basically something like the properties, what the student can have, and the abilities, what the student can. Basically, abilities are what the student can do, and properties are what the student can have. Okay, let's create some. So what are some of the properties that student can have? Of course, student name. Student can have a name. Student can have a roll number. Student can have maybe class. do not get confused with this class and this is like the class 9, class 10, class 11, like that. And that's what I mean. But again, class is not, it's confusing. So let's write standard, right? Which standard are you in? Write that. Okay. Maybe address. These are something that the student can have. So these are called attributes in computer science. These are basically the properties, but in computer science we call them attributes. Now again, what the student can do, what are the abilities that a student can do? Well, a student can eat, and of course it's a method, right? These are methods, these are abilities that a student can do. A student can sleep, a student can study, of course. Oh, what I'm writing, student can study, and yeah. And what are these called? These are the abilities, what the student can do, and we call this methods. Are we clear? This entire thing, this entire rule that how to create a student is called the student class. Basically, the rule book or blueprint, whatever you call it, blueprint. Student class is basically the rule book or blueprint for how to create a student. This is not the student. This is not the student. Okay, student class. This is not itself a student. Okay, it is just a rule book on how to create a student. Okay, now using the rule book, using the rules on what it can have, it can its roll number, its standard, its blah 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 abilities. Now using this, it can create a student. Now this is a student. Okay, and this has some valid properties. Let's say it has his name is basically Raju. Roll number is say roll number 10, standard maybe class 7, address maybe Delhi, something like this. Now this is the student, this is not the student. Okay, this is the student class. This is all about how to create a student. This is the rule book. That's what I mean. This itself is not the car. This is the rule book. This is the rule book on how to create a car. Okay, great. Let's move on. Now, how do we create the object? Using the class. How do we do it? Let's see. So, how do we create it? Let's say this is you. Oh, by the way, before doing it, let's write a class. Okay, let's write a class in Java directly. Let's create a car class. Okay, and today we'll be writing in BlueJ, probably. Yeah, let's write it in BlueJ. Best. Let's open BlueJ. And of course, since we are stepping into object-oriented programming, let's create a separate project itself, right? We are done with all these things, so let's create object-oriented programming. Okay, let's close this thing and let's create our first class. And the class name should be car. Car is the class name. Okay, we are creating the car class. Great. Okay. But before we jump into this, I should write it in VS Code first, so that you understand whatever I'm doing, right? Let's create a folder, right? I already created few, but let's create from scratch. Let's do this. And oopsie, open in terminal, code dot. Alright, here is our VS Code. Let's create our car class. Okay, I would just say car.java. Let's write the code. How do you create it? Of course, since this is the this is the file name is car.java, right? Of course your class name would be car. So public class car. Why? Because the file name is car, so you have to create the public class car. Okay, you do this. Now, very important, do not write public static void main. Do not do this. Okay, because we are not going to directly execute it. Do not do this. Okay, let's first define the attributes. So what were our attributes once again? Our attributes were yeah, what were the attributes of the car? So it had a manufacturer, it had model, manufacturer, model, color. Okay, let's take these three only. Okay, let's take these three. Let's not complicate things. And yeah, let's do this. Okay. And right now, let's not think about the methods. We'll be creating few. So simply write public, directly write here public and string. Oops, not this. Public string. And what are the properties? The manufacturer, the let's not, yeah, the manufacturer, the color, and model, or maybe model, color, whatever. Oh, of course, these are string, right? These are text. Manufacturer would be Honda, Suzuki, Audi, Mercedes, BMW, whatever. Model would be City, Accord, Amaze, maybe Celerio, maybe Swift, something like that. Color would be red, green. So anyway, these are string based, and it is important that you mention public over here. I will show you what this means or what this does, but yeah, these are our properties, or the better words that we use, attributes. We are done. Now how do we create methods? Okay, what were the methods, by the way? Let's create some empty methods anyway. What were our methods? Our methods were accelerate, brake, honk. Let's take these three only. Okay, let's not make it complex. Accelerate, brake, and honk. Okay, let's close it down. Let's go back. Hold on. How do you create a method? Of course, if you have seen our previous videos, how we are creating functions and methods, it's the same thing, right? Public. And one more thing, do not write this. We are not creating static methods over here. I will show you the differences. We are creating non-static methods. That means it is attached with the object, something that the object can do. Okay, non-static methods are something that the object can do. It is binded with the object. It cannot work on its own. It is something that the car would do. And what would the car do? Well, accelerate, and of course let's create some empty methods, and it has to be some return type. So public void, it doesn't return anything, so yeah, let's keep it empty. Okay, we can keep it empty. Let's create, for now let's keep it empty, or maybe write something like this, system.out.println car started, car, yeah, just write car started. Yeah, we are done. Let's write another public void, probably break, and let's write car stopped, system.out.println car stopped. And another one, public void honk, and system dot out dot println beep beep. Okay, these are the methods. So what are these? These are our abilities, or the better word in computer science would be methods. Basically, these are what the object can do. These are what? Let's remove this once. These are attributes, or these are what the object does have. Okay, this is something that the object has. The car can have, anyway, the car has a manufacturer, car has a model, car has a color, right? But what about methods? A car can accelerate, a car can brake, a car can honk. A car has manufacturer, a car has a model, a car has a color, a car can accelerate. Do you understand this? This is something that the object can have, and it is something that the object can. These are the methods. So this is our first class. We are not compiling this at the moment. Okay, let's go back. Let's understand this. So anyway, what were we up to? Yeah. How do we create the object? What is the process of creating the object? Okay, how do we create? Let's say we are trying to create a red Honda City car. Okay, so basically we'll be creating a red Honda City. Do you identify this? This red is the color. This is one of the property. This Honda, this is another property. This is the manufacturer. City, this is the model. Okay, these are the three attributes. So how does it work all together? So if you can identify the properties, let's quickly write it down. So this was what? Let's use a white color for this. This was the color, which is one of the properties. This is the manufacturer. This is another property. This is the model. This is another property, right? Model, color, manufacturer, model. If we go back, these are the exact things that the car needs. Now how do we set it? How do we say to the computer that, hey, I need to create a red Honda City? How do I do that? Let's come back and let's see what's happening over here. So basically, this guy, let's take a pointer for a while. This guy, this is you are the software engineer. Okay, you are the worker, you are the worker. You decide the properties of the car. You decide whether it's a Honda, whether it's a like what's the model, what's the car, like what's the manufacturer, and what's the color. You decide that. And how do you create that? First things first, you decide it. Okay, you call the constructor. What is the constructor? Constructor is a special method. Okay, it's a special method where the object is created. It is a special method where the object is created. It's like a factory. Constructor is a special method within the class that actually creates the object. Think of it like a factory, like a big factory. Okay, this is where all the cars would be manufactured. And who would be doing that? Worker. He will be the one to decide what will be the color of the car. He will be deciding what will be the model, and he will be deciding what will be the manufacturer of the car. And where it will be created? Inside the factory, inside the constructor. This is the special method which creates the object. Think of it like a factory where the object is actually created. Getting the point? We will be writing constructor, don't worry about it. Okay, Let's quickly write a constructor. Okay, what is a constructor? Constructor is a special method that creates the object. You are the software engineer, and you are basically the worker who will be creating, who will be deciding what will be the properties of the car, and you will be creating them inside the constructor. Okay, so this is the factory. We'll be writing the constructor, and we'll be calling the constructor as well. Okay, so you need to pass the properties. You call the constructor that hey, I need to create a car. And these are the properties. Okay, you simply say, hey, I will create a car, and these are the properties. Okay, you give the instruction to this giant factory, and what does the giant factory do? Well, it creates the car. It creates the exact car that you wanted. How? Well, we'll see that. But anyway, it will take the properties whatever you have passed. You have passed Honda. You have passed a Honda, so it will create a Honda manufacturer. You have passed city. This is the model. It will take it and it will create a city model. You have said you need a red car, it will create a red car. So anyway, you give the instruction to the factory then creates, you basically create inside the factory a red Honda city car object. Okay, you create the object, and this is the object. When you pass, let's say you want to create this thing. Okay, you want to create this thing, manufacturer Volkswagen, model Beetle, and color yellow. What do? You simply call the constructor like this. You say, hey, I need to create a car which is a Volkswagen, and it's a Beetle model, and it's a yellow color. You just give the instruction to the constructor, and you know what it will create? It will create a, not this, it will create a yellow, not Honda, Volkswagen, and not city, a Beetle car. Like that, you can create a Lamborghini car. You can say car, I need a Lambo, and the model would be Euros, and the color would be pink, and you give this thing back to the factory. You know what it will create? It will create a pink Lamborghini Euros. Okay, whatever instruction you give to the constructor, it will create accordingly. Again, you need to create this car. How do you do it? You will say car, I need an MG car, and the model would be Comet, and the color would be white, and boom, the Comet will be your factory will create a MG. Your factory will create a white MG Comet car. These are all different objects. These are the objects. Okay, these are the objects. These are the name of the objects. So these are the car objects created by the constructor. These are the actual objects that are created by the constructor. And how does it know what are the properties? The properties are mentioned by the user, sorry, by the engineer or whatever, by you basically. And how do you know what are the properties that it needs? Using this rule book, which is the car class. You already know that the car needs a manufacturer, needs a model, needs a color. You don't have to define all these things. Okay, you don't have to give it to the constructor. Constructor already knows, well, car can accelerate, car can brake, and how. You need to care about these things. Okay, now let's write the constructor. How do you write the constructor? First things first, please define the properties first. That's the first thing that you do. Okay, and then you write a method, and it is the special method called constructor, which is basically method that creates the objects. Okay, let's write the constructor. How do you write the constructor? Do you write public void? No, if you're writing the constructor, you don't need to mention if it is a public or a private. You don't need to mention the return type as well. You don't need to mention int or void or string or whatever. You just write the method name. And what is the method name? Here's the interesting thing. A constructor is a special method, and the name of this method is the same as the class name. So basically, if your class has a name car, your constructor's name would be car. That's it. And this is the method. Here you go. This is your constructor. Do you see what I'm doing? This is the method, okay? But this is a special method, okay? And constructor's name would be the same as your class name. What is your class name? It's car. So constructor name would be car. Simple, right? And what are the things that it will take? It will take a string, maybe, oh, by the way, whenever I am taking something like the parameters, you know, okay, I'll show what I mean. Okay, let's say it will take the manufacturer, or anyway, you can switch, you know, you can, even if you write model here and okay, and then string color here, doesn't really matter, but anyway, you can write whatever way you want to, but anyway, string, I will write manufacturer, I'll write string model. These are the parameters that it is expecting. Please go watch the functions video if you haven't. These are just the same thing. It is basically expecting these things from the user. And string color, these are something that it is expecting. And now, very importantly, it will say the dot manufacturer is equals to manufacturer. What does this mean? This means this keyword means that the car that I am creating, that car's manufacturer would be something that the user passes. But the problem here is, like, there is no problem. You can of course do it like this, it will work. But anyway, this sometimes causes confusion between the developers. So it's best whenever you are writing a class and it has a constructor that takes the attributes from the user, right? Try to put an underscore over here, just to differentiate, you know, but you don't mess up things, right? And now you can type in underscore over here. Yeah, perfect. Now you understand whatever the user passes, say Honda, user passes Honda. Okay, so what will happen? The car that you are creating, that car's manufacturer, this dot means association, that cars, I'm using apostrophe s, that car's manufacturer would be Honda, whatever you are passing. Okay, cool, great. This dot model would be whatever the user is passing, right? This dot color would be color, whatever the user is passing. And when you are done, you can just simply, okay, this step is optional, but if you really want to show that the object has been created, just type in system.out.println and just say that, hey, your car has been created, just like this, maybe created a, and just type in this dot color plus okay, just add a space. I'm just, let's say I'm trying to create a red Honda City, so I want created a red Honda City, something like that. So I would say this dot color plus space plus this dot red Honda, Honda is the manufacturer plus again a little string plus the model, right? Oh, not this, the model, this dot model. And of course, obviously you can print these two directly, but again, you're creating the object, right? Why don't you use the colors directly? Just use the colors. Okay, we are done, we are good. This is how we create the constructor. Let's understand this in a little bit of more detail. Okay, copy this. Let's go back to our blackboard. Let's check what's happening here. This is a long short slide, so it's taking a little bit more time. You paste it over here, and you basically let's make this a little bit more small. Yeah, perfect. So now what do you do? Basically, let's understand what's happening. So say the user is saying car, how do you create object? Okay, this is how you create object. You say whatever the object you are trying to create. Say car object, say write that. Then write the object name, say C1, okay, and write equal to. Now use this new keyword, okay, use this new keyword. This is how you create an object, okay. And then you again, now you call the constructor. Now you call the constructor. How do you call the constructor? Just again, I will just write the method name, and method name is same as class name. So basically just here write this, and now say, okay, what is this expecting? It is expecting the first thing. What is the first thing? It is expecting a manufacturer. Say I'm saying Honda, comma. What's the next thing that is expecting? It is expecting the model. I will write maybe city, and the next thing it is expecting is color. So just type in maybe red, okay. Although I'm writing with green, lol. Once you're done, now let's understand what happens. And now I'll be using white color. So whenever the user does this, it goes back to the constructor. So what is the manufacturer? Honda is the manufacturer. What is the model? It is the model. What is the color? Red is the color. Okay, got it. Now let's start what's happening. So I am saying this. Let's say this is the object. This is the object. Okay, let's say let's create a bad car, and it has a car. I know I'm very bad at drawing. So anyway, this is the car. Okay, this is something that we are not yet created. We are creating. We are creating. So I'm saying this dot manufacturer, that whatever car we are creating, this car's manufacturer is equal to whatever the manufacturer that is being passed, which is Honda. The next thing that I am saying is that the car that I am creating, this car's model is basically whatever the user passed. What did the user pass? City. So it would be city. Great. Then I am saying this dot color. That means whatever the car that I am creating, that car's color would be whatever the user has passed, which is basically red. So it would be red. And we are done. We have created an object, and finally it will print created a this dot color. What is this dot color now? I mean, what is the color of the car? Red. So it will show as created a red. It will take the value from here. Okay, created a red. Of course, a little bit of space. This dot manufacturer, which is Honda, red, Honda, and this dot model, which is city. It will print it. That's how the constructor has already created now an object, and the object name is C1. This is the object. If you try to print system dot out dot print, and you try to print this, that okay, I have C1 dot, I want to see what is the color of C1. You just want to do this. You just do this. You know what it will print? will print red because I have set it to red. Okay, this is how the constructor works. Got it? Great. Let's come back and let's create our first ever object. Okay, let's do this. And when I am doing object-oriented programming, I will be keeping things separate. Notice that this does not have a public static void main. It doesn't have a main method. Okay, so you can compile this. You can compile this thing. Okay, you can say Java compiler. You need to compile this, by the way. You need to compile this for this to work. You can say Java compiler. Hey Java compiler, compile this car.java into a class, and you see here the class has been created. But importantly, if you try to run this Java car, it will not run because it does not have a main method. Because it is supposed to have it is not supposed to have a main method. Okay, I of course could have created a main method, but what's the point? We are trying to keep things separate. We will be creating the object, of course, but not in this class. Let's leave this alone. Okay, let's create another. Let's say test.java. Okay, of course, since the file name is test, the class name would be test. Here you will be creating public static void main string args, and we are done, right? Now here we will be creating the object. Is that clear to you? We will not be creating the object within the same class. There is no point. Okay, we will be creating in a separate class. Just simply say, now say car C1, whatever we have seen over here. We are trying to do the same thing. Car, you write the data type name or the class name, whatever. Then you type the object name. Then you type in this new keyword and then call the constructor. This is how you call the constructor. Okay, so let's go back again. Car C1, this is the object name, is equals to new car. Do you see it is expecting manufacturer, model, and something else, what, and the color. So simply say, let's do something different. Let's say first things first, it is asking for manufacturer. Say I will create a Suzuki car. Suzuki car. The model would be, say, Desire. The color would be, okay, let's create a taxi, right? Let's create a Uber taxi. Let's say white. What will happen now? What will happen now? Let's run this directly. Let's not compile this. Let's directly run this. Let's see. Oh, it cannot find the main class. Lol. Okay, let's compile this. Java Java test.java. Okay, it has compiled. Now let's run it. Okay, now let's run it. Java test. Did you see what happened? Did you see what happened? Now it is showing up. Created a white Suzuki Desire. This is exactly what you told the constructor to create. White Suzuki Desire. This is exactly what you're doing. Now if I try to print it out, I mean, you want to see manually, right? System.out.print, and let's see, right? Let's see. You want to see what is the model name, right? You can say C1.model. Let's print it. What will you get? Let's again okay, we have to compile this again. Lol. Java test.java Java test. Now did you see? It is showing that it has created a white Suzuki Desire, and I'm also printing out it individually that I want to see C1.model. This is like an attribute. Like I am just printing what is the model of C1. Okay, I can print it out individually as well. If I try to print everything, let's print everything. Okay, let's print everything. I want to also see what is the manufacturer. I can type in C1.manufacturer. C1's manufacturer. What is the manufacturer of C1? And again, what is the color of C1? I want to see it individually as well. Let's see. These are the these are how we access the properties directly. Okay. Let's compile this. Let's run this. Did you see what happened? It created the car because I have mentioned that once you are done creating all these things, just print it out. Created a white Suzuki Desire. I have created the constructor. It is doing the exact same thing. But I can also individually, check what is the model name, what is the manufacturer, what is the color. I can access this using dot C1 dot manufacturer, C1 dot color. You can see when I'm checking C1 dot model, it is showing me Desire. When I'm checking C1 dot manufacturer, it is showing me Suzuki. When I'm checking C1 dot color, it is showing me white. What about the methods? Okay, let's see how can we call the methods. It's very simple. What are the methods, by the way? The methods are simply accelerate, brake, or honk. Now that I've already created the object, let's try something. Let's say C1 dot. Do you see these are visible? Let's call accelerate first. It doesn't take any parameter anyway. This is C1 dot brake and C1 dot what else? Also honk. We have honk. Let's try this now. Compile, run. Now, do you see what's happening? Created a white Suzuki Desire, so the constructor is showing, yeah, I have created the car. I have created the car object. You are printing the properties one by one, C1 dot model, C1 dot manufacturer, C1 dot color, whatever. And now you are saying C1 dot accelerate. It is a non-static method. So basically, this car is accelerating. Okay, this car is braking. Do you understand this? This car is honking. Everything that this method is saying, it is associated to this object. Okay, I can call the methods like this. Okay, let's do some modification here. It doesn't give us a lot of excitement, right? What I should say is that system.print car started. And so car started, I shouldn't say like this. I should say rather, I would rather say this dot maybe model is accelerating. Cool. And again, car stopped. This dot model braking is braking. Okay, is braking. So whatever is happening, it will get the data. It will get the attribute. It will get the property of that car and it will show. And again here as well, simply plus, I would rather say this dot model beep beep. Okay, let's save this. We have to recompile this again since we have changed. So whatever the model, let's say for in this case we were using Suzuki, right? We are using model was Desire, right? So it would say Desire is accelerating, Desire is braking, Desire beep beep. Let's try this. Let's compile this. Java car compile. Oops. Java car dot Java compiled. Let's compile our test class. This one. Java. Oh, not here. Java test dot Java compilation done. Let's try this out. Java test. Okay, let's see what's happening. Created a white Suzuki Desire. Of course, this was expected. These are the individual properties that I'm printing out. Pretty easy to understand. Now, when I'm saying C1 dot accelerate, do you see Desire is accelerating? Why it is showing like this? Because inside the method I have said where is the accelerate method? This is the accelerate method. I am saying this dot model space is accelerating. So of course the model I have given is Desire, so it is showing up Desire is accelerating, Desire is braking, desire beep beep, right? That is expected because I have said this dot model space beep beep, this dot model breaking when I'm calling this function. So that is how it works. Now can I create some other object? Okay, let's copy paste the same thing. Okay, let's create something else. Let's create a red Honda city. Now a red Honda city, model name would be city, and this would be Honda. Okay, and yeah, of course C1 is already used. Let's call C2, and VS Code has some amazing tools, so I can use multi-cursor and things. At this point of time I'm just flexing. Oops, C2, perfect. Now save this. So I have created a new C2 object. Okay, this is C1, this is C2. C2 is basically a red Honda city, C1 is basically a white Suzuki Desire. Okay, and I am individually printing the properties, and I am calling accelerate, brake and honk for all of these cars. Let's compile test.java and call java test. Now this is interesting. See what's happening here. First it created C1, created white Suzuki Desire, then it printed the individual properties Desire, Suzuki white. Then you are saying Desire is accelerating, Desire is braking, Desire beep beep. Then you creating C2 object, which is the Honda red Honda city, right? It says created a red Honda city, then it shows up city Honda red. I'm printing the individual properties, right? Model, manufacturer, color. Then it is saying city is accelerating, city is braking, city beep beep. Do you see this? Whenever the object changes, the property changes. I have said that the model is Honda, right? That the model is city, right? So in this case, when it is calling this dot model is accelerating, for C2 it is city is accelerating, for C1 it was desire is accelerating. Getting the point? For C1 it was desire is accelerating because the model name was desire. For C2 it is saying city is accelerating. Why it is saying? Because the model name is city. That's how you can create multiple objects. So we have created objects, we have created a constructor, we are calling them methods for each individual object, we have printed, we have accessed each of the properties. Now can you change the properties individually? Well, you shouldn't do it, but technically you can do it. I mean, if I say c2 dot color is equals to, and I say something like this, blah blah blah, something like this, and I try to print the color once again. Let's try. Will this work? I'm just changing C2's property to blah blah blah. I again somehow do this and I run this. See what's happening. This is the red Honda city. Model is city. Manufacturer is Honda. Color is red. Then I changed it. Then I changed the color to blah blah blah. And now I'm printing C2.color once again. Now I'm printing C2.color once more. But now it is not showing as red. It is now showing as blah blah blah. So this is how you can change the properties. Changing the properties. And this brings us to the next thing, which is that this shouldn't be happening. This should not be happening because it is a misuse, right? Color cannot be blah blah blah. It can be red, brown, whatever, but it cannot be blah blah blah. Am I right? You should not, basically what I'm trying to say, you should not be able to access the properties or attributes directly. Got it? Perfect. So how can we avoid this? We'll be looking into this further. We will be doing this, okay? But before that, let's look into the types of constructors. What? You thought there are only, there's only one type of constructor? No, there are three different types of constructor. The one that we used for the car class is called the parameterized constructor. Why it is called parameterized constructor? Because it takes in parameters. Simple. It takes parameters. This is the constructor that we used, right? This was the car constructor. It was expecting a manufacturer, it was expecting a model, it was expecting a color from the user. So when a constructor is expecting parameters from the user, it is called parameterized constructor. It is the most popular type of constructor that you will be using for all your interviews, exams, whatever. This is the most important constructor that you will be, dealing with. It is basically when the user defines, this is important, when the user defines constructor with parameters. So basically the user has to define this type of constructor, and it will expect parameters. Okay, that's called a parameterized constructor. What are the other two? Well, there is a default constructor. Default constructor is basically when the user does not define constructor at all. When the user does not define a constructor at all, like no constructor, nothing, there is already a constructor given by Java, and it looks exactly like this. You don't have to define it. It will work on its own. No parameters. It doesn't expect any parameters or something. Or maybe you can define it, but with no parameters. Okay, it will be called a default constructor. Okay, I mean, default constructor is something that is not user defined. That is something that the user doesn't define. It is by default, it is there. It is already there. Okay, so if I go back to the example, and I say that, let's not call this, okay, let's say, oh, this, am I dealing with this one or what? Yeah, I was dealing with this one, not that one. Okay, hold on, I need to close this one. Oh, I am in the wrong window, lol. Yeah, I was doing this one. Yeah, right, correct. So if I go back, okay, not this one, of course, not this one. Yeah, right, over here. Do you see what is our constructor? This is our constructor, right? But I'm calling this constructor just like this. But what happens? Let's delete. Let's comment this code out. I don't need all this code, right? Okay, say I am creating a car. I need to call the constructor anyway. I need to call a constructor. Without constructor, you cannot create an object. You need to call a constructor. But say I am saying car C1 is equals to new car, and I'm not passing anything. Will this work? No, this will not work. But what happens if I simply delete this constructor? I have defined the constructor. Okay, let's not delete this. Let's uncomment this out, and let's Javak compile the class once again. What's happening here? Showing me some error or something. Oh, ouch, I missed this line. Yep. So let's compile this car class.java. And also remove all these things just to show you, this works sometimes. Yep. Yeah, this works now. This works now. This doesn't have any kind of method. This doesn't have any constructor, but this still works. And now this is not showing up an error. What will happen if I compile this test.java? What will happen this? Okay, it's asking. Oh, sorry. I first need to compile this, right? Java test.java. Hold on. Oh, I haven't saved it, did I? Lol. Perfect. What happens if I run this test? Nothing. Nothing. Why nothing? Well, I mean, I'm calling the car constructor. I am creating the object, of course. But, I mean, I haven't defined any constructor at all. No constructor. This is called the default constructor. I haven't defined a constructor, but it is still calling the car constructor. Do you see this? This is given explicitly by Java. So there is always a constructor, whether you define it or not. If you define, that is called a parameterized constructor. If you don't define it, then that is called the default constructor. I hope this is clear. Perfect. Let's save this. And of course, I don't need this new line. Again, save this, and we are done. Now, we have seen the parameterized constructor. We have seen the default constructor, which is basically when the user does not define any constructor. That is called the default constructor. Okay. I mean, come on, we are not going to use it. You know that, right? Anyway, but just for information, when the user does not define any constructor, it is explicitly given by Java. It is the default constructor. You can search for the definition in your book or maybe the Wikipedia, but it is what this looks like, and this means. Okay. Then we come to parameterized constructor. Whatever we have done, right? It is expecting a parameter, and we have passed the parameters, and it is working like that. So that is also okay. That is called parameterized constructor. The third type is called the copy constructor. And what does it look like? It looks like your normal constructor, but it takes objects of its own class. So it will not take multiple parameters or something like that. It won't take that. It will take just another car object. Why does it do that? It does it to create copy of object. Say for example, you have a car like this. It's a car, right? Again, I'm not good at drawing. This is a car, and you want to make a copy of this car. So what do? You basically call the constructor. You put this car inside this. Hey, I need this car. You give it to the constructor. I need a copy of this car, and then the constructor creates a copy of this class of this car. Okay. This is what a copy constructor does. Let's create a copy constructor, and let's exactly see how we can define it and how it works. Let's go back once again. Not this one, but this. Remember this. We can define multiple constructors. Okay. Let me write it once again. We can define multiple constructor, and one of them will be used depending on the parameter. So let's define a copy constructor. What does it do? Creates copy of creates copy of its own objects. Let's create the constructor. So let's say car. Again, constructor looks like this. And here's the difference. In parameterized constructor, you are taking the values from the user. You are asking for manufacturer, the model, the color. You won't be doing this time. You will say, hey, just give me a car. You are expecting, like, of course, manufacturer is a string type thing, right? But now you will be taking you will be taking object of your own class and make copy of it, right? It takes object of its own class as a copy. So name it whatever you like to. Let's say obj, or maybe just say car, but anyway, let's write obj. Okay, done. Now what we will do, this is the car object. This is some card that you have given. Okay, it will copy the properties. It will copy the properties of the given car and create a new car. So basically it will do this dot color is equals to, and again you can for first you can type in this dot manufacturer. You can set the manufacturer first, you can set the color first, you can set the model for the order does not matter. Okay, the order does not matter. Anyway, this dot color, it will copy the color from the object. Okay, whatever the color of the object was, it will copy that object's color directly, right? Like for example, we were doing this, right? C2 dot model. It will basically copy the C2 this property and it will put it over here, like this dot model is equals to obj dot model. Now say C2's model was a Honda. C2's model was a city. So what it will do? It will take this city. It will be making another object, and this object's model would be city. You getting it? It is basically used for creating copies. This dot. Oh, what am I missing? Okay, manufacturer is equals to whatever the manufacturer of that given car was. Obj dot manufacturer. Perfect. Let's print something. Print ln probably. Yeah, now let's write created a copy of given car created a copy. Okay, let's write created a copy. It a new this dot manufacturer, maybe Honda, add some space, this dot model plus little bit of string plus this dot color. Oh, okay, it should be the color first. I mean, this looks good, right? Red, manufacturer Honda, model. Perfect. Are we good? Perfect. Now you can see we have two constructors. So which one will be used? It's weird, right? Okay, I'll show you what's happening. Java car.java. Done. Boom, it's gone. Now let's show you some example. Okay, let's show you some example. Let's delete all this stuff. See, for C1 I am creating a new car with this, and I will create another car, C2 equals to new. I will call the constructor, but this time I will pass in C1. Like I literally pass in C1. Okay, What is happening here? Let's run this. Let's run this and let's see what we are getting over here. Java test.java. Good. Java test. Do you see what's happening? You can see created a white Suzuki Desire. Right? Created a white Suzuki Desire. When you are passing the parameters, you have two constructors, but which one of them is called? You can see created a white Suzuki Desire. So that means this is getting printed. Created a white Suzuki Desire. So basically, the first constructor is working. And what's happening next? The next thing is this. Car C2 is equals to new car C1. So basically, you are creating a copy of car C1. Create a new car object C2, which is basically a copy of C1. That's it. You're creating a new car which is nothing but a copy of C1 itself. It is a copy. Do you see what's happening here? Now in the second line, what do you see? Created a copy, a new white Suzuki Desire. So that means when I call the constructor like this, it is not calling this constructor. Rather, it is calling the copy constructor. And what are you getting to see? You're going to see created a copy, a new white Suzuki Desire. So depending on what parameters you pass, it will call one of the constructor. There can be many constructors, and depending on how you call the constructor, one of the constructors will be called. Okay. So basically, let's copy this. Let's go back. Paste it. So this is our test class. Okay. Let's go back. This is our car class. This is too big, right? Let's make it small. Oops, still too big. Okay, perfect. Let's see what is happening here in a little bit more detail. So, when we are saying this, car C1 is a new car, we are calling the constructor, but which one of them will be called? There are two, right? This is a constructor, this is also a constructor. Which is getting called? We are passing manufacturer, we are passing the model, we are passing the color. And which one of them is expecting all this? Is this expecting all this? No. So this won't be called. Which one is expecting all these things? This one is expecting all these things. So here, therefore, this will be called. Okay. That is the logic behind constructors. Next thing is that when I'm creating another object C2 and I'm calling new car and I'm passing C1. So I'm basically passing object of the same class. Which one of them will be called? Is this one expecting the object of its own class? No. Is this one expecting object of its own class? Yes. Therefore, this will be called. This will not be called. And you can have multiple constructor, and one of them will be used depending on the parameters, and this is, my friend, called constructor. This is called the concept of constructor overloading. We will be looking, and it is a part of polymorphism. Do not worry, I will be covering these all in further videos. But anyway, this is called constructor overloading. Why constructor overloading? And it is a part of polymorphism. Why? Polymorphism means, this means one thing can have many forms. Many forms. For example, in this case, both are constructor, but both are different things. This is a parameterized constructor. This is a copy constructor. This is polymorphism. One thing can have many forms. Okay, not just two forms. You can define 4 constructors if you really want to do that. I don't know why you would be doing that, but you can do that. Okay, we don't need to do that, of course. This is called constructor overloading, and it is an example of polymorphism. Okay, so basically this line will be calling this one, and this line will be calling this one, depending on what you pass. So what exactly is happening? So the thing that is happening is that you are creating a copy of C1. So basically, if C1 has a red color, C2 will also have a red color. If C1 is a Honda, C2 will also be a Honda. It is basically a copy. Okay, it basically creates a new car object. The name is C2, of course, which is basically a copy of C1. Now let's see this in a little bit more detail. Oh, by the way, this video will be long, and do not try to cover this video in one go. Otherwise, everything will just, everything will be just messed up in your head. So don't try to cover this. So let's open up. Okay, let's try this. How is this exactly working? So if I say system.out.println, okay, system.out.println, and I'm saying C1 properties, okay, something like the C1 properties, and I'm just simply printing this. Like I'm simply saying this dot color plus little bit of space. Oh, sorry, not this dot color. I'm not inside the lol method. C1 dot color, a little bit of space, plus C1 dot red, maybe red Honda City, right? So manufacturer, the manufacturer plus the model of the car, C1 dot model. What will this print? And of course add this, and let's do the same thing for C2 as well. Let's change it to C2, and again I'm flexing the capabilities of VS Code, multiple cursors, C2. Perfect. Let's save this, and again let's Java compile this and run this. See what is happening. First things first, it is creating a white Suzuki Desire. Great. I mean, this line is creating a white Suzuki Desire, the C1 object. Okay. Then it is saying created a copy, a new white Suzuki Desire. So it is creating a copy of it. In the second line, it is creating a copy of C1 object using the copy constructor. Great. Now I am printing the properties. So C1's properties are white Suzuki Desire, and C2 is a copy of C1, so its properties are also white Suzuki Desire. So we have created a copy. This is the concept of copy constructor. Simple. But I just want to show you why this is a copy. Like for example, if I change, say if I let's say I change C2 dot color is equals to, let's say, green. something like this. I change the color of C2. Will C1 be affected? Question is, will C1 also be affected? Basically, like this. Let's print the same thing once again. Let's change something more. C2 dot model is, let's say, Swift, or not Swift, let's call it Alto. So the question is, will C1 also be affected? I am changing C2's color and C2's model, so will that affect C1 in any way? Let's see. There's only one thing to see. Let's compile and check. Compiled, run. Let's see what's happening. First things first, it is creating a white Suzuki Desire. It is creating a copy of the white Suzuki Desire, that is C2. Now, before changing anything, C1's properties are white Suzuki Desire. C2's properties are also the same, of course, because these are the copies of each other. Now I am changing C2's color to green and C2's model to Alto. Is C1 getting affected? Let's see. C1's properties are still the same. It is still the white Suzuki Desire, but C2's property have been changed. Green Suzuki Alto. Green Suzuki Alto. This means that let me copy this. Yep. C1 will not be affected because C1 and C2 are copies of each other, but they are both different objects, right? So changing the color of C2 won't change the color of C1, and again changing the color of C1 will not change the color of C2 as well. Getting the point? That's why we can change the features later on. So basically what I'm trying to show you is this. Let's go back. So this is what the copy constructor is doing. Okay, this is C1, this is a copy constructor. You basically say, hi, I need a copy of this. It gives you a copy of this. This is a completely new and a separate car object. Changing attributes of C2 will not change the attributes of C1, and vice versa. Say I want to make this blue. Let's make this blue. Okay, let's make this blue. Again, I am bad at drawing. Let's make this blue. Yep. Did this change? No. Let's make this yellow. Did this change? No. That is what I am saying. It is a completely new and separate. This is very important. They are separate objects. Yes, they are copies. Yes, they are copies. Correct. But they are separate as well. This is the concept of copy constructor. So I am actually creating two objects. I am actually, if I have a RAM, this is the RAM, and this is C1, this is the object. I am creating a copy of C1 as C2. Then I have two different objects. Okay, if this is occupying 2 MB in memory, this is also occupying 2 MB in memory. So basically 4 MB of RAM is now gone. That is what I am saying. Same concept. These are twin brothers. They are copy of each other. Perfect. They're copy of each other. Okay, that's not a big deal. But say Satyendra and Jitendra, they are both twin brothers, so basically they're copy of each other. But important thing is that they are different person. So if Jitendra decides I don't want to wear maybe yellow, I want to wear probably red. Okay, I want to wear red. Okay, let's cover it, right? I'll do this. Great. If I do this, this will not affect Satyendra. Why? Because Satyendra is a different person and Jitendra is a different person. But initially, they are copy of each other. Okay, so Satyendra is a different guy, Jitendra is a different guy. The next question that you will be having is that why do we need a copy constructor? Isn't it? That will be your question. Why do we need a copy constructor? Can't we just copy it like this instead? Like when we copy an integer variable, how do we do it? We generally say int x is equals to 10 and int y is equals to x. So y is a copy of x, right? Thus y is a copy of x. So can't we do this? Like create a car object c1 and create another, like just say car c2 is equals to c1. Can't I do this? Because I'm saying car c1 is equals to new car and I am putting all the parameters, let's say Honda, Red City, whatever, and oh well, we have c1. Can't we simply say car c2 is equals to c1? This will not work. Why will this not work? Well, let's check. Okay. Let me quickly open this and let's see if this works or not. Okay. In fact, let me try opening JShell over here, and since we are in the same folder, JShell probably will detect the car class, but let me check once. JShell, will this work? Let's see. Let's try to create a car object. Okay. Again, this is in JShell, so you don't need to write all these classes and methods anyway. So I'm just trying to create a car. C1 is equals to car. Car needs three things: the manufacturer, the model, and the color. Say the manufacturer is Audi. Say the model is A4. And say the color is red. Okay. That is our car. Let's see if this creates a car object. Okay, it cannot find car. Okay, so JShell cannot clearly detect it. Cool, no issues. Let's do it over here only, okay? Let me remove all these things. I don't need all these things. Let me just clear. Okay. Yeah. So, what I was saying, let's create a car object. Car C1 is equals to car. And let's create an Audi here. Audi. Red. Oops. Yeah, anyway. Let's create a Audi A4 and red. Yeah, I forgot to put the new keyword anyway. New. And this thing. Okay. So this works clearly, right? Well, great stuff. So I created an object. That's okay. Let me close this JShell. Yeah. So I created an object. That's fine. Now let's try to create a copy of this car C2 is equals to C1. Will this create a copy? Let's see. We have the copy constructor, by the way. Okay, we have the copy constructor. If this copy constructor is called, then we will get to see this, that created a copy, a new, blah 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 will be created. But let's check. Let's try to run this. And let's see if this works. Okay, let's see if this works. Fine. System.out.println. Let's try to print some of the properties of C2. Okay, C2 dot maybe color, and of course C2 dot manufacturer, and of course C2 dot model. Okay, let's first simply print it. Okay, java test.java, compiled it, java test. So first, what do you see? You see created a red Audi A4. Okay, because you, of course, you called the normal constructor, and yeah, it went here and it, this method was called and the car object was created. That's pretty much fine. Then I said car C2 is equals to C1, but this time the copy constructor was not called. this thing was not called. I didn't call this. I simply said C2 is equals to C1. And now I'm just, now I have another object C2, and now I have another object C2, and I'm trying to print the color of C2, the manufacturer of C2 and model of C2. Now this works pretty much fine. So is this a copy? I don't need to create a copy constructor or something. Is it so? Is it so? Looks like it, right? C1 has a color of red. C2 also has a color of red. C2 also has a color of red. C1 is an oddie. C2 is also an oddie. C1 is a A4 model. C2 is also an A4 model. So did we finally create a copy in an easier way? No, this is wrong. This is not a copy. Why not? Well, let's see. Say I change C1 dot, let's say change color of C1 is equals to green, and save this. Okay, cool. So C1's color has changed. The next question that comes is, will this also affect C2? This is the question. You might say, well, C2 is a different object and C1 is a different object, so it shouldn't offer it shouldn't affect C2, right? Let's check. Let's print both the colors. Okay, let's say system.out.println color of C1, and of course put it over there, C1.color, and then system.out.println and say color of C2, and put the color of C2 dot color. Okay, let's save this. Let's compile this and let's run this. Did you see what happened? Focus over here. Did you see what happened? Exactly. I changed the color of C1, but when I'm trying to print the color of C2, this has changed. So whatever you change for C1 will affect C2 as well. Changing any property of C1 will affect C2. Did you get it? Doesn't matter, whatever I change now, it will affect. For example, let's try to do this. C1.color. Let's say change the model. Okay, model to A6 probably. Okay, A6, and again just copy paste this. Again, let's flex some of the abilities of VS Code. I'd say model. Yep, model of C1 and model of C2, and try to print this before the change. Okay, this is before the change. After the change. Let's try to see what's happening over here. Yeah, let's check this out. Copy, paste, save this. Let's try to compile this. Let's run this. Do you see what's happening over here? Listen to me very closely over here. Oh, what's the first thing? You are creating a new car, brand new Audi A4 red. Great. You are saying C2 is equals to C1. Okay. Now you are printing C2's color. Of course you are getting red. You are printing C2's manufacturer. Of course you are getting Audi, and the model is A4. And this is expected because C2 is equals to C1. You think it is a copy, right? but this is not a copy. Why this is not a copy? When we initially print it, we see that, well, C1's color is red, C2's color is red, C1's model is A4, C2's model is also A4. You think this is a copy, but this is not a copy. Why? When we change C1's color to green and when we change C1's model to A6, listen, we didn't change C2. We did not change C2 here. We changed C1, not C2. Now when we try to print color of C1 and then color of C2, what do we get? Color of C1 is green, color of C2 is also green. But I didn't even touch the color of C2. Model of C1 is now A6. It was previously A4 and I later changed the model of C1 to A4. But that was C1. Here I am seeing the model of C2 has also changed. Exactly. This is the case. Hence, this is not a copy. This is a reference. This is a reference. And we will understand what reference is. Basically, what happens is that whenever you change C2, C1 will get affected. Whenever you change C1, C2 will get affected. For example, this here I have changed the properties of C1, not C2, but C2 also got affected, right? I changed C1 to green, C2 also became green. I changed C1 to A6, C2 also became A6. Can it be the opposite? Let's say I say C2 dot color is equals to blue, okay, and C2 dot model is equals to say Q2, okay. Changing properties of C2. Here I was changing the properties of C1, but here I am changing the properties of C2. Question is, will this also affect C1 now? This is the question. Let's find out. Copy the same thing and paste this, save this, compile this, okay. Compiled. Let's run this. What do we see? Again, first of all, a red OD is created. Red OD A4 is created. We are printing the properties of C1, right? We are printing C1's. Oh no, we are printing C2's property. So you think it is a copy? Yeah, okay, good, okay. So initially color of C1 is red, C2 is also red. Model of C1 is red. A4. Model of C2 is also A4. But then we change C1's color to green and C1's model to A6. So of course color of C1 is green now. I have changed it. But C2's color also has changed to green. I have changed model of C1 to A6. That's good. But model of C2 has automatically changed to A6. Now what I am doing is that I am changing C2's color. I am not touching C1. I am not touching C1. I am changing C2's color to blue and C2's model to Q2. Will this also affect C1? Oh, well, let's check it out. Color of C1 is blue. Here's the interesting part. Color of C1 is blue, but I haven't touched C1 at all. I haven't touched C1 at all. Right? Did I? No, I didn't. I changed C2's color. But here what's happening? C1 is also changing. C2 is of course going to be changed because I have changed it. I have changed C2's model to Q2. But do you see even C1 is getting affected? So yes, changing any property of C2 will also affect C1. That is the problem. Okay. So basically what I mean is that when I say C1 is equals to C2, it does not mean C1 sorry, when I say car C2 is equals to C1, it does not mean that C2 is a copy of C1. It means C2 is just another name for C1. They are referring to the same object. Am I clear? So hence, if you change attributes of C1, the same changes will be applied to C2 and vice versa, because they are the same object. Okay, what is happening here? Let's understand. Let me give you the concept. This is called, whenever you say car C2 is equals to C1, this does not mean copy. This does not mean a copy. This means reference. This means C2 is a reference to C1. Are you getting it? C1 is not a copy of C1. Okay, C2 is not a copy of C1. C2 is a reference of C1. Okay, what this means? When I say this is our car 1 C1, okay, great. I say car 2 C2 is equals to C1. Like I literally put this car over and I thought, well, C2 is a copy of this car. No, it is not. This is not a separate object. This is literally the same object C1, but now has another name C2. It has another name. So now it is basically the same object, but it has now two names, C1 and C2. So it doesn't matter what you change. Doesn't matter what if you say C1 dot color is equals to red. This color, like this will also be affected. This will, because see, this object is same. Previously it had only one name. Now it has two names. That's it, nothing else. But they are the same object. They are not separate. So if you change C2's properties, C1 also changes, because it is the same object. They are the same object. So that's why I have already shown here. If I say C2 dot color is equals to green, and I print C2's color, of course I'm going to get green. But even if I print C1's color, I'm still going to get green. Why? Because now previously C1 was basically this car. Okay, this was C1. Now you know what this is? Car is the same car, no change. But now it has two names. It is also called C1 and it is also called C2. I will explain you the concept in a better way using the real life scenario. Is this again? Well, let's take the Satyendra's example. This is Satyendra. Okay, this guy is Satyendra. Now Satyendra is his school name. This is the school. In school, this guy is called Satyendra. Okay, but the same guy at his own house is called Sattu. In school, he is called Satyendra. In his own home, he is called Sattu. But Satyendra and Sattu both refer to this guy. So basically, if I say this is the object, okay, this is the object. This object has two names, Satyendra and Sattu. Okay, got it? if I say Sattu dot color is equals to red, what happens is this: his shirt color becomes red. This becomes red. Now if I ask the computer, hey, tell me what is Satyendra's color, if I say print Satyendra's color dot color, what is the color? What will I get? What will I get? Well, I will get red. Why? Because Satyendra and Sattu, they are basically this guy, same guy with both the names, right? So if I change Sattu's color to red, of course Satyendra's colors also become red because it is the same guy, right? So it is the same concept. One object, multiple names. So basically what I am saying is that this is the object and Sattu is the reference of this object. Satyendra is a reference of this object. Okay, are you getting my point? When I say car C2 is equals to C1, when I do this, car C2 is equals to C1, C2 is the reference to C1, not a copy of C1. Whenever you change C2, C1 will get affected, and whenever you change C1, C2 will get affected because they are both the same object. So basically inside RAM it looks like this. Inside RAM it looks like this is the RAM. Okay, this is the RAM. All your variables and objects and whatever, it runs over here. Okay, this is your car object. This is your car object. I'm just saying car object, whatever. Okay, now when you say see what's happening. Okay, let's do it. When I say car, I will say new car and some properties, say red, Audi A4, something like this. The moment this constructor is called, a new object will be created in the RAM that has this property. It has red, it has Audi, it has A4, and it has also the methods, right? That like honking and braking and accelerator, whatever. And of course I cannot just write it. I always say car C1 is equals to new car this. The moment I am doing this basically means that this object that was created, it will be called using C1. It has one name. Okay, so basically the entire line, when we write car C1 is equals to new car and we give all the properties, it basically means this inside the RAM. But when I say car C2 is equals to C1, this means that the same object has another reference, another name called C2. So it doesn't matter what you change. If you say C2 dot color, it will mean this. If you say C1 dot color, again it will mean this. And if you try to change, let's say C1 dot color is equals to blue, this red will be gone, blue will become instead. Now if you try to access, hey, what is C2's color, you will get blue, although I have changed C1's color. This is the concept of reference, not copy. This is reference, whereas this is actual copy. Okay, these are separate. That's why I said in this case what happens is that if you say, let's go through the process once again, the copy constructor, right? When you say car C1 is equals to new car, you call the constructor and you give the properties, right? Red, Audi, right? A4, whatever, you give the properties. The moment you do this, now what happens is this is our RAM, this is our object. This object will have all the properties, say red, Audi, A4, and all the other methods as well, right? All the methods as well. What are the methods? Start, stop, honk, whatever, all the methods that we created. And I am saying C1 is the reference. So basically what will happen? It will have a name called C1. Correct? Now what happens? Look closely. If I now say car C2 is equal to new car, I am calling the copy constructor now. Car C1. You know what happens? You of course know what copy constructor does, right? What does copy constructor do? Copy constructor just copies the colors and models and manufacturer and just makes a new object. What happens now? This is what happens now. The moment you try to do this, you are creating a new object. That's why we use this new keyword. Whenever you see new, it means a new object that is created inside the RAM. Whenever you see this new, it means a new object that is created within the RAM. So in that way, you will have another object which has the same properties. Why? Because this is again a copy constructor. It will just copy whatever the property that was given and create a literal separate new object. This will have again red, Audi, A4, and it will have all the methods that we mentioned. And by the way, this will have a name C2. Okay, that is the difference. But whenever you do something like this, that let's say we have something called car C3 is equals to, let's say C2. You know what will happen now? The moment you do this, what was C3? What was C2? This was C2. This is C2, right? And this was only having one name, C2, right? Now the moment I said car C3 is equals to C2, this object will have another name. This object will have another name, which is C3. So basically, this object has now two separate names. They are not two separate objects. C3 and C2 are not separate objects. They are the same object. Okay, this is called reference, whereas this is called copy. We are literally creating a new object, but here we are not creating a new object. We are just giving the reference. That's the concept. That is why we need copy constructor to actually create the object. That's why I gave you the example of the twin brothers. Jitendra and Satyendra are two different guys. If Jitendra changes his shirt's color, that will not affect Satyendra, right? But in this case, what was happening, if Sattu changes his shirt's color to red, Satyendra's color will also be the red, because Satyendra and Sattu are the same person. That is reference and this is copy. So you might ask, then what about other data types? What about other data types? I mean, when you say int x is equals to 10 and you say int y is equals to x, is this a copy or is this a reference? Is this a reference or is this a copy? This is still a reference. This actually, you are not even creating a copy. This is your RAM. This is 10. This is the integer object. Integer is also like, think of it like an object or something in your memory. And this has two names. This has two names, x and y. Perfect. So now you will say I do something like this. I say y is equals to 15 now. So this 10 will become 15. No, this is not going to happen. Why? Integers are not mutable. They are immutable. You cannot go within 10 and just maybe say put a 5 between and make it 150. That is not possible. Integer doesn't work like that. It is immutable. If you are trying to create 15, then it will create 15 separately in the memory. Okay, we'll create 15 separately in the memory, and now y will no longer point to this thing, rather y will be pointing to this thing. You got it? Y will be now pointing to 15. So I am not changing the object itself, rather previously y was pointing to this, y was pointing to 10, and now y will point to 15. That is what happens with integers, strings, etc. Got it? That's how the things work. Say what are mutable? Well, there is something called arrays. Okay, array is a list of items, say 1 2 3 4 and 5. If you do something like this, okay, let's come to array a little bit later. Let's take an example of strings. Okay, let's take a example of strings. Say string a is equals to hello, and string b is equals to world. Okay, or rather string b is equals to a. What happens now? This is what happens. You will have a string inside RAM called hello. This will have a name. This name is basically a. Okay, now you're saying you have another string b which is pointing to a or referencing to a. Okay, when you do this, when you say b is equals to a, what happens? This hello will have another name b. But importantly enough, the moment I say b is now is equals to, let's say, world or something like this, what will happen? Nothing much. This arrow will now vanish. A new object will be created, which is basically world, and now b will basically point to world, not to hello. That is how it is with the immutable types. Okay, this is what is in, because think about it logically. Okay, say I say something like this: a is equals to 10, b equals to 10, c equals to 10, something like this. Okay, or maybe like this. Java works like this. Say this is our RAM, this is the 10, and a is equals to 10, b is equals to 10. It will not go and create a, b and c. It will not do like this. It will not go and say this is a, this is b, and this is c. No, that's not going to happen. For example, if c takes 2 MB, b takes 2 MB, and c takes 2 MB, bro, that will be 6 MB. I mean, come on, it's integer, it will not take that much. But anyway, point is they are not separate. You know what happens instead? What happens instead is this: the 10 is created. 10 is already created. Right? Okay, let's take this is the RAM. 10 is created. Now 10 is referenced by A, 10 is referenced by B, 10 is referenced by C. So how much memory does your RAM take? Only 2 MB. I mean, I'm just an example. Whereas if you have managed it like this, it would take 6 MB. Java does this, not this. Okay. So what about mutable data types? Immutable means something that can not be changed. Let's come to a new page. Let me show you. Immutable means something that cannot be changed. For example, int say if I say int x is equals to 10 and I have a RAM I have 10 and it points to x now, and I immediately say x is equal to 15. X is equals to 15. Now what will happen? We'll have another thing, 15, another object, and now x will point to this, not to this. But it is not going and changing this to 15. That is not happening. It is separately creating 15. It is not going and just removing this and replacing this with, no, that's not happening. This is why it is called immutable. It cannot be changed. If I say string a is equals to hello, and maybe I go and somehow say a is equals to somehow do some calculation and blah blah blah, and I make it hello or maybe cello. If I do something like this, well, you know what happens? The moment you do this, you have something called the hello. It now points to a, but the moment you say a is equal to cello, it is not going there and replacing h with c and then it is pointing to a. That is not happening. You know what's happening? This is what is happening. Separately cello is created. This arrow will vanish, and now a is pointing to cello, so this will happen. That is how these are called immutable. What is mutable then? Well, this is what mutable looks like. Mutable means something that can be changed. For example, car is an object. Okay, this is our car. And let's call it C1. This is C1. This is mutable. Why is this mutable? C1 has three things. C1 has a color, C1 has a model, and C1 also has a manufacturer. Initially, say color is red, model is okay, maybe what are some Indian models? I can't remember. Maybe Celerio, and manufacturers, let's say Suzuki. Okay, basically if this is the RAM, this was C1. Inside the C1 we have three things: red, we have Celerio, and we have Suzuki. Okay, and this is basically C1. Okay, what is mutable? I can go ahead and say C1 dot color is equals to green. You know, I can go ahead and do this. I can say, let's do it here. C1 dot color is equals to, say, blue. You know what will happen? This will be gone now. Here blue will come. So basically this is now gone. Blue will come. Do you see? This is mutable. It's something that can be changed. So C1's property is actually changed. It is not happening that another thing is being created and then there's blue, then Celerio, and then no, that's not happening. Within C1 you can go and change it. I can somehow and go and say model is equals to alto. You know what will happen? This will come over here. So alto. It will be replaced by alto. This is called mutable. These are mutable. And since these are mutable, you cannot go ahead and say car C2 is equals to C1. You cannot do this, because if you do this, it's not creating a copy. It is rather creating a reference, which is C2. Now when you change anything in C1, it will affect both C2 and C1. In this case, what was happening? If you are saying that say int x is equals to 10 and int y is equals to x, what was happening? This is the RAM, this is 10, that is pointing to x, and it is also pointing to y. But then when you change y, say y is equals to 30, it doesn't go ahead and destroy 10, right? It just removes the pointer to 10, it creates maybe 30, and now y points to 30. In this case, this is the reason you can do this. You can technically do this, and this is considered, although technically this is a reference, okay, but we can say that this is the copy. Why? Because it doesn't go and changes this. Why? Because these are immutable. So for immutable things, you can do, say you can do these things. Int x is equals to something, say 10, and you go int y is equals to, you can do this. This is okay for immutable. But whenever it is mutable, you cannot do this. You cannot do this. Nope. At least for objects, you have to do something like this. Car C2 is equals to new, call the copy constructor, and put in this, that is C1. The moment you do this, then what will happen? This will no longer be happening. A separate object will be created. Remove this thing. This will have the different properties. In fact, the same properties. If it is Blue, Alto, and Suzuki, it will have the same properties. Blue, Alto, and Suzuki, it will have the same properties, but it will be a separate object, C2. It will not be the same object. Hope that is clear, right? Great stuff. So now let's come down to something called the garbage collector. Let's understand this little bit more detail. Again, this is our RAM, right? This is our RAM. Say we are doing something like this. Int x is equals to 10, and I am changing to x is equals to 30. I am saying x is equals to 40, x is equals to 60, x is equals to 70, something like this. What is happening now? The moment I do this, let's do this. Int x is equals to 10. 10 is created. It is now pointing to x. Then I say x is equal to 30. 30 is created. This is removed, and rather x is now pointing to 30, right? And then I say x is equals to 40. What happens now? 40 is created somewhere in the RAM. The pointer is removed to 30, and x is now basically pointing to 40, correct? Then I say x is equal to 60. 60 is created somewhere in the RAM. This thing is removed. X now points to 60, right? Then x is equal to 70. 70 is created. X now points to 70, correct? So what happens to this? If I say each of them is 1 MB, each of them, so 1 MB, 2 MB, 3 MB, 4 MB, 5 MB, they are getting wasted. Why? Because there is no need of 10 at the moment. Is something pointing to 10 at the moment? No. So why keep it in the RAM? Is anything pointing to 40 at the moment? No. Is anything pointing to 30 at the moment? No. Is anything pointing to 60 at the moment? No. Why keep it in the RAM? Remove these all from RAM. Remove this all from RAM. Remove this. Who does this job? Here comes the garbage collector. What is garbage collector? Garbage collector is a memory management system program that runs in the background in Java virtual machine. Okay, because all the Java code anyway runs within the Java virtual machine, right? See, the flow is this. If you do not remember, you write your source code. This goes into the Java compiler. it creates a bytecode. This code runs, this code is run by the JVM. Now within JVM you also have something called the GC, garbage collector. What this does? Garbage collector automatically collects objects that are no longer required and removes them from RAM to free up resources. Right now your RAM is getting used 5 MB now. If you remove this, how much MB left? Only 1 MB. And that is this, and that is actually required because X is anyway pointing to 70. That's how you save your RAM. That's how you manage your memories, right? I'm just giving you a small example. What if there are tens and thousands and millions of lines of code? This will be a huge issue, right? And this does not only happen for integers, it happens for everything that you create in Java. Everything. Say for example, if I clean this up, again I have a RAM, and say I have an object here. I have say some value, say a car. Say for example a car. Let's say a red Audi A4, and of course the methods. And say it is getting pointed by X. Okay, so basically I'm saying basically I'll be saying something like this: car X is equals to new car, and the properties whatever required. So this is what's happening. Okay, but then after some time I say X is equals to something else, something else. So anyway, the pointer to this thing gets removed. Okay, this is no longer required, so this will be removed. Who will remove this? GC, the garbage collector, and it will do it automatically. This is very important. This will do it automatically. So basically what it is a system management. This is like a system program that manages the memory. It comes up, it automatically checks, okay, well, this is not required, this is not required, remove this from RAM. These are called garbage collector. Do you see? These are the objects that are no longer used. They are removed from the RAM. In other programming languages, there might not be a concept of garbage collector. There is something called suspense. There is something called the destructor. You have learned about constructor, right? What is it? It is a method that creates object, right? What is the destructor? Let me write it in red since it is the destructor. What is a destructor? Again, that is a method that destroys object. Basically removes them from RAM, destroys objects. And this concept can be found in languages like C++. Inside C++, you don't have the you have the concept of destructor. Constructor looks like the class. Let's say you are creating a car class. It will look like a car, and this will what it will look like. Destructor would look like this. Car. Let me write it in red again. R. Same. Looks like the constructor, but before writing you have to write this sign, tilde. This is called a tilde sign. This is the destructor, and this concept is inside C++, not in Java. In Java, you have the concept of garbage collector. It comes, it checks, and it automatically checks the objects that are no longer required and removes them from RAM to free up resources. That's the concept of garbage collector. Perfect. Okay, let's quickly begin with some theory. And now that you have done all these things, it will be now very easy for you to understand what I'm saying, right? Let's see. Encapsulation, right? In encapsulation, what is encapsulation? The important thing that you have to know about encapsulation is this thing, capsule part. What is object? What is object? Object is nothing but a combination of attributes and methods, right? Attributes are the properties, methods are the abilities. So consider attributes to be half capsule and methods to be the other half of capsule. When you add both of them, you get the full capsule. Simple. If this is the car, if this is a car, These are the attributes. The manufacturer is Volkswagen, the model is Beetle, the color is yellow. This is the half part. What is the other half? Well, the abilities, the methods, what it can do. Accelerate, brake, and horn, like honk. This is the other half of the capsule. When you mix both of them, when you mix what it has, that is the attributes, and what it can do, the methods, you get the full capsule, that is the object. This is the concept of encapsulation. It is basically combining attributes and methods together. Okay, so this is the concept. Now we will be moving on to the next concept, that is abstraction. Well, this is really easy to understand. You know what is abstraction? It is basically hiding. Simple word, abstraction means hiding. Let me explain. This is the switch that you see in your home, right? And you just turn it on, right? You just click it, boom, just turn on the switch on. Whenever you turn it on, the bulb gets turned on. Whenever you turn it off, the bulb is off. I mean, basically, if you think that this is an object, you would just say s1.on, it will get on, s1.off, it will get off. Simple, right? Only on and off. This is the only thing that you can see and use, right? You can only see this and only use this, right? But you cannot see the internal structure of the switch. You can see the switch, you can turn it off, turn it on. So basically, you can see the switch. The internal circuit or electrical connection is not visible. You can only use the switch to turn on or off the bulbs. You cannot modify the internal connection. You cannot modify the internal connection, right? This is what it looks from inside. There is the switch. When you press the switch, I mean, you see this is basically the electrical connection. But this is what you cannot see. What you cannot see, and you don't care. And why do I say that? Let me explain. For example, when you are this is taking a little bit more time. When you are creating a scanner class, what do? Import Java dot util dot scanner. Oh, sorry, scanner. You import this, okay? When you try to create the object, how do? You say scanner sc is equals to new scanner system dot in. You do this. Now you have the scanner object. Now if you want to take integer from the user, you would say sc dot next int. What this does, takes integer input, correct? But how? What is the code? What is the code inside next int method? Well, that's where you can't see, at least in here, and you don't care. You don't care what it has. You don't care how it calculates, how it takes input, blah blah blah. You don't care. You know how to use this and you use it. That's it. If you want to just press a switch and turn on the bulb, you don't need to become a electrical engineer to understand the circuits and the complexities within the within the process, right? You don't need to be an electrical engineer. That's what I mean. That's what I mean. You will only use this object to turn on and off. You don't know what is the off method. I mean, what is the code, or you don't care. You don't care, and you can't see this. This is called abstraction. The internal complexities are abstracted, basically hidden from the user. This is the concept of abstraction. Okay, you cannot go in and, well, let me do some magic here, let's change the circuits. You cannot do that. You cannot do that. Why? Because you can't see the internal structure. That is called abstraction, and you also don't care. It just reduces the complexity, isn't it? Right? Oh well, you don't care what the electrical circuits are here, you just turn it on. It works. Happy life. This is abstraction. Okay. Now, two more things left: the static, the non-static, and the access modifiers. Well, let me begin with the access modifiers first. Okay. Let's go back, come down, and okay, let's have this and let's remove all these things. All these things, okay? Don't need all of these things. Hope you have noted it down. If not, go back and note the things down. Okay. Right now, the problem with this is, I mean, if I try to say that C1 dot color, I can get it easily, right? I can just, if I want to see what is the color of C1, what is the color of C1? If I want to ask this question, I can simply go and say system.out.println, and I can say color dot C1 dot color. Simple. I get the color. But the problem is, I can also change the color like that. C1 dot color is equals to blah blah blah. Now, if I print the same thing once again, it will change. Let's compile this and let me show you. Compiled, run. Oops. Compile, run. See what is happening. Created a red ODF for, I mean, this is fixed. We are calling the constructor and we are creating the new object. Great. First, I am just checking what is the color of C1. So I'm just printing the I'm just printing C1 dot color. I'm getting red. Okay, this is expected. But I can also change it. I can say C1 dot color is equals to blah blah blah, some weird thing, and it will change the color. Now when I print C1 dot color, it will show me blah 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 instead. This is not a good coding practice. This should not happen. I mean, this is not the right way to do this, you know. You shouldn't be, technically, you should not be able to directly access attributes generally. When you're working as a software engineer in a company and you're building real software, you cannot just say that why is this happening at the first place, because I have said this to public. Public means it can be accessed anywhere, outside the class, within the class, anywhere. Okay, anywhere. Got it? And that is the reason I can change it, I can access it, I can do all these things. I can do all these things. Right? Now, if I don't want this, I can just remove this public thing. Rather, and try to see what's happening. Okay, let's save this. Just remove this and save this. Let's compile the car class, Java car.java. Okay, and now do this again. Let's see if this can still be accessed. I have removed this public thing, right? There was this public string, so I have removed public. Will this work now? Is.java, or just try to run it. Okay, run it like it is. I haven't changed this, so there is no point of compiling this again. Just say Java test. Well, it is still accessible. It is still accessible. Why so? Because when you don't specify anything, this is what happens to your code. Listen, when you say public, you can access it anywhere and everywhere. Okay, but when you remove public, when you don't put anything, let's say I say public string name, if I do something like this, then this is public and it can be accessed anywhere and everywhere. This should not happen. So what happens if you remove public? The moment you remove public, this is what happens. It becomes default. It can still be accessed anywhere, but only in the same package. Package is basically the folder. I am not going into detail of package. That will be covered later in some other video. But basically, the moment you remove public, it becomes default. If you don't put anything, if you don't put any access modifier, any access modifiers, this means default. This basically means it can be still accessed anywhere, but only in the same folder. But that means if I come here and see the folder structure, what is the folder structure here? We have this folder called practice. So do you see this? We have a folder called practice, and within this practice we have car.java, we have test.java. So it is in the same folder. Car and test are in the same folder, therefore it can be accessed. No point, doesn't work. So how do you make it something that test.java cannot access? How do you do that? Well, you can come here and rather say private. Boom. Did you see what happened? The moment you did this, this became red. Why? This became red. What is saying now? The field car.color is not visible. You can't directly access something like this if you try to do that. Oh, well, this is not it compile. Oh, I haven't compiled the car, right? Okay, let me compile this again. Rather, compile done. You see what is happening now? The car field is not visible. You cannot do that. You cannot do that. If you try to do that, you know what will happen? See what is happening. Okay, you created a new car. Very good. You created it. Good. But then the moment you try to do this, system.println c1.color, what's happening here? It is basically saying illegal access error. Class test, that is this class, tried to access private field of car.color. Okay, test and car are in an unnamed package, basically unnamed folder. Okay, do you see the problem? Problem is that it is getting you illegal access error. Why? Test class is trying to access the private field. It cannot do that. It cannot do that. Okay, this is not allowed. You cannot go ahead and access private field. So how do you access it? How do you access this? This will be your question. How do I access it then? You cannot directly access it, but you have to create something called the getters and the setters. What do you have to create? You have to create getters and setters. But before you go there, the moment we do something like this, we say private. It cannot be accessed anywhere, nowhere except the same class. What does this mean? It cannot be accessed anywhere outside the class. Anywhere, not the same folder, not the child classes, nowhere. Okay, only the same class. This basically means, do you see this? These are all private, right? Manufacturer, model, and color. But I can still access this dot manufacturer, this dot I can access this, but within its own class. I am accessing manufacturer, model, and color and everything, but within its own class. That is allowed. But outside the class, it's not allowed. Okay? Inside the class, it is allowed. Anywhere you can use it. Outside the class, it is not allowed. So we have to take advantage of this, and let's see how we can do that. First things first. Okay, let's not do this. Okay, we have to create something called getters and setters. And before doing that, what about this? What about protected, or this thing? Well, we won't understand this unless and until we complete inheritance, child classes, and all. These are things that we'll be learning in when we learn about inheritance. Okay, inheritance. But basically, protected means that in the same folder you can access. You can access in the same, anywhere in the same folder, and you can also access within the child classes. Okay, we will look into it when we go to inheritance. For now, we will be using private directly when we don't want the properties or the attributes to be accessed outside. Okay, let's check. So what do we need? How do we access them? Well, we need something called the getters and setters. Right? Getters and setters, right? So let me show you what I mean. Basically, I want you to create, say, private string name. Say for example, name. Okay, or say roll number. Let's say you are using you're dealing with some student class, right? Private string or private int, probably private int roll number. Let's say I'm dealing with student class, right? I have something like, and then I will have a method. I will say public int, because it will basically give you integer, and its name would be get roll. Okay, get roll. And you know what it will give you? It will simply return this dot roll, and that's it. Now let's say you have a student object, say student s1 is equals to new student, and you enter the details, right? Whatever. Now you cannot go ahead and directly access s1 dot roll. You cannot do that. This is not allowed. Rather, what you can do is this: s1 dot this method get roll. This will give you whatever they say the roll number is 30. This will now give you 30. This will not work. This will work. And this is a good coding practice. If you these things are called getters. What? Getters are, I mean, that's just a fancy name. It's nothing. It's just a regular method that gives you your attributes, right? Getters are basically methods that return private attributes. Okay, I mean, that is how you can see the attributes. Okay, you cannot directly access it, because if you could have directly accessed it, you would have simply said s1.roll is equals to maybe something like this, maybe 5216, something like this, right? You can do this, but you can no longer this is not going to work. It's not going to work. If you try to do something like this, let's say you are dealing with the student class again. Let it load. Again, you're dealing with the student class. Say student class. I'm not writing the entire thing. This is the student class you're dealing with, and inside you have again you have the private int roll. Of course, you have that method, right? You have that method. What was that method? To get the roll number. To get the roll number, you are using public int get roll. This is the getter. What it will do? It will simply say return uh, this dot roll, and it will basically give you the roll number of the object. That's it. But there is something else also. What if you want to go and say, I mean, you basically want to do the same thing. You let's say you are doing something, student say s1 is equals to new student dot dot dot, whatever the constructor value you are putting. You want to set something s1 dot roll is equals to 5002, but this will not be allowed. You cannot directly access a private variable, and there is reason for that. Come on, 5002 cannot be a roll number, right? That's a lot of roll number for a classroom where only 30-40 students get to sit. So basically this is not allowed. You will rather do something like this. Let me clear this off, and let me put it over here. So rather what we will be having is something this public public void. You don't need to return anything, so simple void set roll. To set the roll number, you will have a method set roll. It is expecting an integer, say some x value or some whatever, no, and it will you can directly set it. Of course, you can set this dot roll is equals to x, and this will set it. But this doesn't make any sense. Come on, like if it is that simple, then I could have simply made it public, and I would have said like s1 dot roll is equals to whatever 10,000 or whatever. This shouldn't be done, right? We should have a logic for setting roll number. In fact, I would rather say if x is, let's say x is more than 0 and x is less than, say, 50, only then I would set it this dot roll is equals to x, whatever the user provides. I would set this. Else I'd say error or something, or just don't do anything. Just say, yeah, anyway, just close this. Okay. If this is the case, roll number will be changed, or it will not be changed. Now, if I want to change this guy's roll number, I would rather say s1 dot set roll, and I will give the roll number. Say if I say 42. Now if I try to okay, this is done. Now if I try to get the roll number using this method, and I say s1 dot get roll, this will give me 42 because I already set it to 42, correct? But of course, if I set it to some random, let's say 100, this is not going to work. I mean, if I do give get roll, I'll still get 42 because this is the logic. If it is like less than 50, only then it will set it. Otherwise, whatever it was previously, it will be that only. Okay, hope the concept is clear. These are called setters. So the things that give you the attribute values are called getters. Well, I mean, you are getting the value. Okay, and setters are the methods which lets you set the attributes value. Okay, with some logic or something, add your own logic or something, like you can do that. Okay, great. Well, let's quickly, this car class is already too much, so let's create a new class rather for our own benefit. I just remove all of these things, right? Let's create a new class over here. Not this one, not this one. Yeah. let's say student dot class. Oh, I created class, lol. Not this, not this. I mean, just delete this. I have to create Java, right? Not this. Let's delete this. Perfect. Let's create this student dot Java. Public student, public class student. Okay, perfect. Say private string name, private int role, and standard as well, whatever the standard is. Yeah, that's it. Not anything more. Okay, that's it. Create some methods and let's try to do this. Okay, first create the parameterized constructor. It's easy. Student, and it basically takes the name. It will take the roll number. I'm putting underscore for avoiding confusion. You can just write roll, and it will also take the standard. Okay, and what it will do, it will simply say this dot name is equals to whatever the name user is providing, this dot role is equals to whatever the name user is providing, and this dot standard is equals to whatever the standard user is providing. And we are basically what? Oh, I forward an underscore over here. Yeah, okay, cool. And I will also print that the student created system dot out dot println. I will simply say student space the name of the student, this dot name plus name with roll number space. I'll put the student's roll number, this dot roll in standard, whatever the standard of the student, this dot standard other is created, and that's it. That's our parameterized constructor, easy peasy. Let's create some random methods. I just want it for the sake of completeness. Say public void study. Okay, and let's say it will expect a subject, and it will simply say system dot out dot println whatever the name of the student is, this dot name simply is studying whatever the name of the subject that the user is providing, subject. Okay, great. Yes, that is enough. Okay, and these are all private. You cannot go ahead and say s1 dot name. You cannot do that stuff. Let me try it out. So student s1 is equals to new student. It is expecting a name would be Ravi, roll number would be say 20, standard would be say 10, I guess. Yeah, so that is okay. Student is created. Let's just do this, compile this and run this. Java test.java, this is done. Java test Okay, so it is simply creating a student. It is saying student Ravi with roll number 20 in standard 10 is created. Okay, so Ravi studies in class 10. He has a roll number of 20, and yeah, his name is Ravi. Good, we are good. But we can't go ahead and say system dot out dot println and hey, what is the name of the student? You cannot do this. Why you cannot do this? Try it out. It is saying name has private access in student. You cannot access a private variable. Name is a private variable here, right? You cannot go ahead and access this. To access this, you need a getter. You need a getter. Let's create the first getter. Public. It will return a string. Remember that. So public string get. Just write the get. Just write get, and then whatever your attribute name is, get name. Of course, it won't expect anything, and you just return this dot name. That's it. And do the same thing for the other ones as well, roll number and standard. Okay, so just go ahead and say public int row, get roll return this dot roll. Just give out the roll number. Then again public int standard. Oh, sorry, get standard. Get standard. Return this dot standard. That's it. These are our what? These are our getters. This will get you the things. This will get you the things. Okay, let's try it out. I cannot do this, but I can obviously go ahead and say something like this. I can say s1 dot get name. I can do that. This will work. Similarly, system dot out dot println s1 dot get roll. Similarly, system dot out dot println s1 dot get standard. So basically each of these methods returns, it directly returns. For example, getName will return, it will take the value and it will return it, and I'm just printing it out. You cannot just write this thing because this will not work. You're not printing anything. We'll just get it, but it doesn't work like that. You have to write in println. Why? Because it is returning, it is not printing. This returning, this is not printing it directly. So you're getting it over here. Now it is your responsibility to print it out. Check the functions video if you do not understand what I mean, right? Anyway, let's try this out. Let's compile this and check for ourselves. Java test. Wow, this works. So I'm getting the name Ravi, I'm getting the roll number 20, and I'm getting the standard 10. Perfect. Now if I want to change the standard, can I go ahead and say s1 dot standard, not this, s1 dot standard is equals to say 100. I cannot, right? This is not visible at all, right? If I even try to save this and I want to compile this, it will simply give me an error. It will say standard has private access in student. I cannot go ahead and do this. Okay, so I need setters for this. And of course I'll need to apply some logic into it, because I cannot just go ahead and dumbly put any number. 100 cannot be a standard, right? Generally in Indian schools we have from standard 1 to standard 12. So anything outside of that range is invalid. You cannot do that. So let's go ahead and create some setters. So for setters, I have to say public, and again setters don't need to return anything. So anyway, just put in void. Public void set roll. Let's start with the first one, roll, right? I would simply say if say your if oh, again it will expect a roll number, right? You need to put what roll number you are trying to set. So anyway, int roll, whatever roll you are trying to set, and again just enter underscore just for avoiding confusion. I'm gonna say if whatever the role that the user is providing is greater than 0 and the role is less than 100 or maybe 50, okay, then you can set it. Then you can set this dot role is equals to underscore role. Then only you can do this. And by the way, you can put this entire thing in the same line. I know I should have put it like this, but yeah, you can avoid it. Okay, let's try the next setter. But for if you're writing an exam, try to do it in this way rather. This dot role is equals to underscore role. You can try this as well if you're writing an exam. Anyway, public void set name. Now I cannot think of a logic for setting name. If you can, just implement it, but for now I'll just take the name from the user and I will just simply set it. I mean, this dot name is equals to whatever the name the user is giving, right? You can put some something like you cannot set this name, that name, that's up to you. But anyway, public void set standard. It will expect a standard name, say standard. Right. Again, the logic would be here, at least in Indian schools, standard has to be greater than 1 and less than or equals to 12. Greater than equals to 1 or less than equals to 12. So I would rather say if the standard that the user is providing is equal to greater than or equal to 1 and the standard is basically less than or equal to 12, only then this dot standard would be set to the standard that the user is providing. Alright, we have the setters now. These are the logic, okay. And of course, let's put the else part as well. I mean, come on. Else system.out.println invalid roll number, and I can do the same thing over here. Else system.out.println invalid standard, and we are good. Let's try this out. Let's compile this. Java student dot java is compiled. Let's try and test this. Let's say I want to say s1 dot set sets. Let's first set the name. Let's set the name is Rohan. Let's see if this works. Not. Also, let's try. Okay, let's set all the things. S1 dot maybe set role. I have to put something less than 50. Let's say 34 probably. And let's try to do something funny. Let's try to set standard as 1000, something like this. Let's see what happens. And by the way, once these are done, after the change, println just to show the user after the change. Again, I will just print it. All these things. I just want to get the things right. Let's paste it. Save it. I'll get the name, get the roll number, get the standard. Let's java test.java. Compile this. Okay, compilation successful. Java test. Run this. See what is happening. So first of all, student Ravi with roll number 20 in standard 10 is created. Name is Ravi, roll number is 20, and the standard is 10. Okay. What happens then? You set the name to Rohan. Perfect, no issues. You set the roll to 34. It is less than 50 and more than 0. So, okay. You try to set the standard. You try to set the standard to 1000. But I have a condition here. What did I say? If I said, if and only if the standard is more than equals to 1 or less than equals to 12, this will be set. Otherwise, invalid standard will be printed. And that is what is happening. You try to put it 1000. Oh, sorry, this one. It is showing up invalid standard. Right? This line you try to put the standard to 1000, which is not valid. So it is showing up invalid standard. After this, it is showing after the change, that is this line. Again, you are trying to get the name, which is changed to Rohan now, the roll number, which is changed to 34 now, but the standard hasn't changed. Why? Because of this, you did set it to 1000, and 1000 was not set, right? This is not meeting the condition. So it is what it was previously. It was previously 10, and it is still 10 because it was not changed, right? So, but Rohan and 34, these are the new values, updated values. Rohan because of this, 34 because of this. Okay, so this is all about getters and setters. Let's move on to the last topic. I'm already tired. The last topic would be this. We have studied access modifiers, at least in a very high level overview. Public means anywhere and everywhere. Private means nowhere except the same class. Default means when you don't give anything. It is accessible only in the same folder, not anywhere else. Protected, will look it when we are using child classes. But anyway, it is only available in the same package and its child classes. But now these are access specifiers. Now these are access specifiers, that was access modifiers, these are access specifiers. Now access specifiers can be anything. It can be static, it can be non-static, it can be transient, it can be synchronized, but we don't need to look at all those things. Those are out of the scope at the moment. We'll be looking into two things, non-static and static. For now, we'll be looking into the non-static ones, non-static access specifiers, since this is the main thing that we are dealing for now, right? We have dealt till now. So, what are non-static methods? Well, speaking very frankly, these are methods that are related to the object. For example, when I am using the car class, okay, if I say set color, and I give some, this is the setter, okay, some setter that I already have shown you, right? So set color, if let's say I put something, let's say red or something, this will change the color of that object. Say if this is our car, and I say, and this is, let's say, C1, and I immediately say C1 dot set color, and I say red. So this is changing C1's color to red. This is related to the object directly. Okay, what are some other examples? Set speed. Again, if this is our car, some car, and I say, and again this is C1, I say C1 dot set speed to 100 km/h. The speed of C1 is going to change. I mean, the point is that it is related to the object. That is what I am trying to mean. Similarly, the attributes, okay, color and the model, these are not static. These are non-static attributes. Again, attributes can also be non-static. Methods are also non-static. Attributes can also be non-static. Okay, why are these non-static? Well, because, let's go back a little bit. Yeah, let's come back here. Do you see this? When I say this is the model, right? Let's say this is C2. Okay, this is C2. If I say C2 dot color, just this c2 dot color. Okay, what will I get? I'll get pink, because I am asking for c2's color. I don't care c1's color, c3's color, whatever. I'm asking about c2's color. When I say c1 dot color, I'm asking about this object's color. So this is binded with the object. Are you getting my point? Similarly, when I say c3 dot let's say model, I am asking about c3's model, which is comet. This is binded. c3's model. I don't care about c1, c2 or any other object. c3's model is comet. This is binded to the object. Similarly, if I say c3 dot honk, so c3 will be beep beep. c3 will do that, not c2, not c1. If I say c2 dot break, c2 will break. So it is binded. The non-static methods or the non-static attributes both are binded with the object. I have taken another example. Let me go back. Yeah. Let's take another example. In this case, using the student class, study. Study is a non-static method. Why? Because it is binded. It is binded to the object. If I say s1 dot study and say I put maybe science, and we already have created this class, what it will say? It will say, let's say s1's name was Ravi. It will say Ravi studying science. Okay, this is non-static method. If I say sleep and I say 5, it will say Ravi sleeping 5 hours. It is binded with this Ravi guy. Okay, it is binded with the object. That is why it is called non-static method. Okay, if I, let's say role, when I say s1 dot role, I'm talking about Ravi's role. When I'm saying s1 dot name, I'm talking about Ravi's name. When I'm saying s1 dot study science, I'm saying Ravi is studying science. When I'm saying s1 dot sleep 5, I'm saying Ravi is sleeping for 5 hours. Do you get the point? When I say c1 dot color, I'm getting Lamborghini Urus's pink color. It is associated. It is associated. It is related to the object. Getting the point? Let's see this in action. What I mean? For example, I just remove this and I say s1 dot study and I say history. Compile this and see what happens. Javak and Java test. What it is saying? It is saying student Ravi with roll number 20 in standard 10 is created. Of course, we are calling the constructor. Then I am saying s1 dot study. What it is showing? Ravi is studying history. If I create another student, let's say, let's take this, let's create another student. Let's call it s2 now. Let's call it s2 now. And I say Rohan. Rohan, let's say he studies in 12th standard, roll number is maybe 10, something like this. And he's not studying history, he's probably studying maybe computer. And I save this. Java test. What do you see here? What do you see there? You see student Ravi with roll number 20 in standard 10 is created. Student Rohan with roll number 10 in standard 12 is created. Now when you call s1 dot study, then Ravi is studying. Whereas when you say s2 dot study, it is saying Rohan is studying computer. Okay, so this study method is associated with each of the object. You can't say s2 dot study will show Ravi is studying and Rohan both are studying. No. If I am saying s2 dot study, I am saying Rohan is studying. It is binded with the object. Okay, that is what I mean. Rohan is studying, Rohan is sleeping, or Rohan is eating. Okay, Great. So what about what about static methods? Well, story is just a reverse. Let me show what I mean. This basically means it is not related with the individual object. Just the opposite thing. For example, let's give you an example with the student class. Let's say you want to have a method that counts how many students passed out by a year. How many students passed out by a year? Let's say in 2018 somebody passed or something. So what I'm trying to say is that if you have something, say I want to, okay, this is taking a little more time. Yep. Say I have some in 2018, let's say 10 student passed. In 2020, 5 student passed. Something, I have something like this, you know, and I want to create a method called what was the method name again? Count pass out by year. Count pass out by year. I will just need to enter what is the year that I'm looking for. Let's say 2018. Okay. And now this will basically return 10. Now the thing is, why is this static method? Because I'm not asking about Rohan individually or maybe Ravi individually. I'm not asking about individually. I'm literally asking a general question that how many students passed in 2018. Will count. It will have some logic again. Abstraction. Okay. I don't know what the logic is, but anyway, it will just give me 10, the number of students passed in 2018. This is not something that has to be binded with Rohan or Ravi or the object, right? This is a general question. That's when the static methods comes in. Right? Just like the math library. Similarly, what about this? Total students. So if I have a variable static int total students and I'm accessing this basically means how many students objects did I create. Maybe 20, maybe 30, whatever. This is again not related to Rohan or Ravi. This is a general thing. This is a general attribute, general property, not related to the object. That is when you have to use static. When using the car class, if I really have to give an example, let's say I have a method, calculate pollution. Is it related to some car? No, it is not. So it shouldn't be a non-static function. It should be a static method rather. Count cars by year. Again the same thing. Is this something that is associated with the object? No. Total cars. Is this associated with a particular car? No. For example, if I have, let's go back quickly. Boom, boom, boom. So if I have a static attribute called total cars, it will every time increment by 1 the moment every car is created. So 1 plus 1 plus 1. This should give me 3. So this should be a static method. A static attribute. This should be a static attribute, not something that that is associated with C1 specifically or C2 specifically C3. This is a very general thing. How many total cars are there? 3. This is static. Okay. Cool. Go back once more. Again, what is the maximum popular brand? Honda, Suzuki, Audi, BMW. Again, this is the general thing. Okay. So this is again static. Let's go back and give you an example of static. and finish this video. So basically, if I go back here, say I have a private, again I am putting private for the sake of security, static int total students, something like this. This is a static variable, sorry, a static attribute. This will count total number of students. Okay, every time the constructor is activated, every time the constructor is called, it will do what? It will basically increment this total students plus equals to 1, or simply total students plus plus. Again, you don't, do you see the difference? I didn't say this dot total students, I simply said total student plus plus. Why is it so? Because this is not related to the object. This is not something that the object has. This is the general thing. This is not related to the object. That's why you don't need to write this dot total student. You can simply say total student plus plus. Basically, every time this constructor is called, this will be incremented. Let's create 3-4 students and let's check this really works. Let's copy this. Yeah, S3, again let's call S3 and say say Ratan, roll number 5 and standard 6. Perfect. Ratan studies history, no, science. Okay, cool. Now how do I get this? Can I do simply system.out.println, and I'd say s2 dot total. You can't even see total students. Why? Because it is not associated with S2. What about S3? It will not work. What about S1? It will not work. So how do you get that? To get that, you can simply say class name dot, what was that attribute? Total students. Copy this, paste this, save this. But anyway, this will not work. You know why? Try to find the answer. Okay, Java test. Why? Because it will say total student has private access in student. It has a private, of course. I should have did this, but anyway, okay, this will not work. Why? Because it is private. I have mentioned private here. Of course, you can remove this thing and compile this. Now this will work perfectly fine. Again, this is not the right way to do. You can try to do this. You can compile this. Oopsie. Compile this and say Java. Did you see this? 3 total student. This is how you call. So how do you call static attributes? Simply say, let it load, static attributes. How do you call this? You simply say class name dot attribute name. For example, in this case, we used student class. Student dot, what was the attribute name? Total students. That's how you get it. Static attributes. Okay, great. Note it down. This is how you call static attributes. Let's go back. This is how you calling static attributes. if public. If public, this is very important. If this is public, only then you can call this directly. But if this is private, you cannot do this. You cannot do this. See, it became red instantly. It cannot be accessed anymore. So how do you access a uh, private static attribute? Well, same concept. You need a setter, but you cannot just go ahead and simply create a setter. You cannot say public void. No. You cannot do that. I mean, yes, of course you can do that, but that is not the right way. You can say you need a getter, sorry, not a setter. You can go into the getter section and you can of course go ahead and say public int get, what was the name, total students, and of course you can return total students. You can do this, okay? This is not something wrong. You can absolutely do this. You can know, but the problem is, see, this is a static attribute, right? But you are defining a non-static method to get a static attribute. Isn't it weird? I mean, yes, I can go ahead and I can do the silly thing, right? I can say system.out.println, and I can go and say s3.get s3.get total students. I can do this, right? And I will get the value as well if I just compile this now. Java test. I am getting this, okay? That is not the problem, but I am somehow indirectly associating it with the object. Even this will give me the actual 3 only, right? This will give me 3 only. Even if I do it like this, S1, it will still give me 3. I am getting the point. But I am associating this static attribute with an object, which is not right, okay? So that is the reason. Do not make this a non-static method. Don't do this. Rather say public static int get total students, whatever. Don't associate it with the object now. Rather do this. Rather do this. Call the static method instead. How do you call a static method of other class? Student dot get total students, and you're done. Calling the static getter when the static attribute is not public or basically inaccessible. This will work perfectly fine. If I compile this, oh, this is working. This is perfectly. So there are 3 students. What I'm doing in the constructor, every time a new student is getting created, I'm incrementing this integer variable, right? I'm incrementing it every single time. Initially it is 0, then 1, then 2, then 3. I have created 3 students. It will be 3 students. But important thing is this getter is not a non-static getter. Why not non-static? I could have made it non-static, but that doesn't really make sense, right? Because total students is a static attribute and I shouldn't associate it to a particular object, so that's why static getter as well. So how do you call a static method? How do you call a static method? Simple. Anything static. Start with class name dot method name, whatever, right? In this case we were using student dot get total student. That's how you access static method, and that's how you access static attributes. Hope this is clear. Okay, we are very close to it. We are done with getters and setters, static and non-static, everything. Now in the car you can test something out. You can make it public, private, whatever. Let's keep it public for the moment, and you can play around with it. And if you are really oh, by the way, let's take the example of math library. If you have worked with it, every method in math library is a static method because it is not associated with the object, right? I mean, for example, if you have ever used math library in Java, how do you import it? You would say import java.lang.math, something like this. You import it, and then you say math is the class. Remember, math is the class. Math dot say round, and then you give some number, maybe 5.6 something. But do you see what is this format? Class name dot method name. What is this? That means this is a static method. This is a static method, and this is okay. Because come on, you don't need to create a math object for that. Math obj is equals to, this is stupid, right? You don't need to, because round is not related to the object. Like, it is a very simple thing, right? You don't need to relate everything to the object. Okay, great. Anyway, just to give you a brief demo in BlueJ as well, let me show you. Let's open BlueJ. Oh, by the way, you can copy paste things. I am not creating everything once again. Where's our BlueJ? Okay, car. Hey, let's copy these things, you know. Or rather, I'll just copy this. Hey, BlueJ crashed or something? BlueJ crashed, yeah. Let's open BlueJ. Okay, I don't need anything. Just remove this. I will just copy and paste things. Okay, copy this, come here, paste this, save this, and of course compile this. Class compile, no syntax error. I have another class student. I did create student, right? Again, I'll just paste the same content once again. I have already created the student class. Copy this, copy the entire thing, come here, delete everything, paste it, save it, compile this, class compiled, no error. Then you have the test class, right? Yeah, right, test class. Again, just copy paste things, copy, go back, delete everything, paste it, save this, compile. So it is pointing to a class. What? Student class. Why? Because I am using the methods of student. I'm creating objects, anything like this is related to student, right? That's why. So this works. I'm giving this a demo, like demo. Compile this, and if you try to really see what's working, what's not, let's run this. It is working perfectly fine, as expected. No issues. By the way, can you run this? You cannot run this. Why you cannot run this? Because it is not meant to be run. You can of course put a main method inside this, but please don't put a main method within this student class or car class. These are meant to be separate classes. If you really want to do that, do it in a separate class like test. Here you put the main method and run this instead. Run this, not this or that. Run this test. Okay. So that's how do it in BlueJ as well. yeah, I mean that's it. If you really wanna do it, try something else. Let's create a math class. This is pretty weird, because Java already have a math class. But hey, come on, let's try this. Let's create our own math class and just type in public static int add. It takes two number x and y, and it returns x plus y. Weird, right? Stupid. Add things. Again, just paste, paste, paste. Okay. And just remove add, subtract, multiply, and maybe divide again, but divide is generally gives you double, so just change it to double. Divide, multiplied, subtract, and this. Yeah, we're done. We're done. Again, we don't need a we don't need a main method over here, because this is a separate class. If I really want to use the methods of this, I will use it in a separate class. Maybe in test class I would do this. I'd rather go and say something like this. Let's try this out. I can go ahead and say math. I can directly use it. I don't need to create an object. I don't need to say math m is equals to new math. I don't need to do that. Why? Because, well, I don't have any non-static method as there as well. I can just simply go ahead math dot add, and I can simply say 10 comma 5, and see if this works. It should give me 15. Yeah, now it is pointing to math library. Sorry, a math class. Lol. Compile this, test this out. Yeah, it is. Is it working? Yeah, it is working, but I'm not printing anything now. I mean, this is returning something, but I'm not printing. Let's print it out. System.out.println. Yeah, perfect. Now let's compile it again. Run this one more time. Yep, working fine. 15. So that's basically it. These are our hold on. Okay, so we are done with all these things. You can try create some of the static methods, static attributes. Try it out on your own. If something doesn't work out, just let me know. Yep, I have given you some of the examples, at least for the student class. Try making your own for the car class. Right, try doing this. You will get a little bit more sense, how things work. You really need to practice all these things. I know it's a lot. Access specifiers, access modifiers, static, non-static with private and public and all. There's a lot of things I know. This video is very long. Go through it very slowly. If it requires, watch it, rewatch it again and again. But give this video the highest importance of all the videos that I have made till now. So alright, that's it. See you in the next video. Bye bye.